Welcome to this explainer. Today, we're unpacking a massive, and I mean literally, game-changing shift in the technology landscape. We're looking at how a German company, Neura Robotics, just secured Europe's largest robotics funding round ever to build the future of physical AI. This isn't just about cool hardware. We are talking about completely redefining how machines learn, how they work, and even how they transact.
Here's our roadmap for today. First, the billion-dollar bet. Second, the physical AI pivot. Third, training in the Neuro Gym. Fourth, the Neuroverse network. And finally, the new machine economy. Let's jump right in.
Section 1. The billion-dollar bet. Let's look at this monumental financial milestone that is completely reshaping the European tech scene as we know it.
$1.4 billion. It's a staggering number, right? Neura Robotics recently closed a record-breaking Series C funding round for up to that $1.4 billion amount, which pushes their estimated valuation to roughly $7 billion. That massive influx of capital firmly places them among the absolute most valuable robotics companies on the planet.
Now, what makes this cash injection so fascinating is this unprecedented, unified backing from major industry giants. You've got Tether leading the charge, sitting right alongside American tech titans like Amazon and Nvidia, plus deep-rooted European industrial backers like Bosch. This level of cross-continental trust for a hardware startup, it's incredibly rare, and it tells us something massive is brewing.
Section 2. The physical AI pivot. To understand exactly why these giants are handing over such astronomical sums of money, we really have to look at the urgent, real-world problems driving this shift.
Look, as Neura CEO David Rieger points out, we are living in a rapidly aging world. By 2030, we're staring down projected skilled labor shortages of 7 million workers in Europe alone, and a staggering 80 million in China. The traditional workforce is shrinking fast, and honestly, traditional robots simply cannot fill that gap.
So, the solution requires a complete pivot. Think of traditional industrial robots as, well, really expensive washing machines. They execute rigid programs and fail completely if a part shifts even a fraction of an inch. Cognitive robots, however, are more like intelligent interns. They actually use sight, touch, and sound to learn, adapt, and react to completely unscripted, chaotic environments.
Neura's physical embodiment of this cognitive leap is their flagship humanoid, the 4NE1. It stands 180 centimeters tall, weighs 80 kilograms, but get this, the truly remarkable spec here is its 100-kilogram payload capacity. That significantly outperforms competitors and proves this machine is built for heavy, meaningful physical labor.
This quote perfectly captures the core philosophy. A cognitive robot perceives its surroundings using 3D cameras and hypersensitive force sensors, processes that data with AI, and then acts. It survives the messy, unpredictable real world because it can actually improvise.
Section 3. Training in the Neuro Gym. Okay, so the crucial question is, how do you actually teach a cognitive robot to effectively operate in that chaotic, physical world? It's not as simple as uploading a file.
CEO David Rieger asks this brilliant foundational question to explain their training philosophy. How do you teach a robot to swim? I mean, you can't learn to swim just by reading a PDF or watching a video, right? Eventually, you actually have to get in the water and feel the physics. This philosophy builds a continuous training pipeline for physical AI. It starts with teleoperation, so humans demonstrating tasks to get exact robot hand data. Then it moves into high-fidelity simulation before entering physical gyms for rigorous real-world practice where the robot fails, corrects itself, and eventually masters the task completely.
To let these robots touch that metaphorical water, Neura is literally building physical gyms on a massive scale. Built in partnership with the Technical University of Munich, right at Munich Airport, this is a 2,300 square meter facility opening in mid-2026. It's dedicated entirely to letting hundreds of robots practice tasks and collect massive amounts of real-world data.
Section 4. The Neuroverse network. Once a single robot masters a complex skill in one of these massive physical gyms, how does that actually benefit the rest of the fleet globally? Enter the Neuroverse. Think of this as an intelligence marketplace, or basically a cloud-based hive mind. It's a shared learning platform connecting every single operating unit together, creating a massive central infrastructure for physical AI.
The efficiency gains here are just mind-blowing.
Historically, isolated learning meant each robot required weeks of manual, individual programming by engineers. But with the Neuroverse, if one robot figures out how to pick up a tricky new type of packaging in Stuttgart, every single connected robot globally knows how to do it, instantly.
This shared knowledge network dramatically reduces deployment time from weeks down to mere hours. On top of that, third-party companies can contribute skills to what Neura calls a robot's brain account. This open ecosystem is designed to help scale production to tens of thousands of units by 2026, and they are aiming for millions of active physical robots by 2030. We're talking about revolutionizing entire supply chains practically overnight.
Section 5. The New Machine Economy. Now let's explore the most sci-fi, conceptually heavy, and honestly fascinating part of this $1.4 billion deal, the integration with Tether.
The technology Tether brings to the table starts with QVAC. This is an edge AI system. It essentially ensures that advanced AI models run locally, directly inside the robot itself, rather than constantly depending on a remote cloud server.
And this local processing, it's absolutely vital for physical machines. If a robot is driving a car or holding a heavy object, it cannot afford high latency, and it certainly can't just freeze up if the warehouse Wi-Fi drops. Edge AI guarantees instant, offline decisions, which dramatically enhances human safety.
But Tether is going a massive step further. They are integrating their Wallet Development Kit, or WDK. Yes, you heard that right. They are literally equipping these advanced cognitive robots with their very own self-custodial digital cryptocurrency wallets.
This creates a completely new paradigm. Just imagine if your smart car could pay for its own gas. A robot independently performs a physical task, the system verifies the work is done, and boom, the robot automatically receives a cryptocurrency micropayment directly into its wallet. It can then turn around and use those funds to pay for its own electricity or maintenance. No human banking intermediaries involved at all.
As Tether's CEO Paolo Arduino notes, this hardware and software mashup lays the direct groundwork for a decentralized machine-to-machine economy, an economy that he suggests could one day rival or even completely exceed the scale of the human economy.
And that brings us to the end of our explainer. We've seen how cognitive robots, massive training gyms, cloud hive minds, and decentralized digital wallets are blurring the lines between physical labor and digital finance. It leaves us with a fascinating and highly provocative question to ponder. When a robot can learn on its own, work on its own, and transact entirely on its own, who really controls the new machine economy? Thanks for joining me on this deep dive. Keep questioning, keep learning, and I'll see you next time.